Hello everyone, you are welcome to my YouTube channel. In this video, I will talk about closures. A closure is a function object that remembers values in enclosing scopes, even if they are not present in memory. Closures can be used to implement a variety of features in Python, which includes decorators. These are functions that modify other functions. Callbacks. These are functions that are passed as arguments to other functions. They are often used to implement event-driven programming. Partial functions. These are functions that are partially applied with some arguments. They can be used to create reusable functions that can be customized with additional arguments. Let's take examples. Here I have a function greeter, okay, that takes an argument name with an inner function which returns an S string of hello name, okay, and then the outer function then returns inner, okay, the function name, not the function call. If we run this, okay, we have the greeter function in our namespace. Now I can call a variable greet. Okay, I have a variable greet which is assigned to greeter and Python. Okay, next, because this function, okay, outer function greeter returns just the function name. To print the result of this, I need to print greet with the function call. So if I run that, if you called it without this function call, what it will return is the function expression. So it's telling you that we have if you are calling a function greeter, okay, dot locals dot inner. In other words, you are calling, you have a outer function that is calling an inner function and then gives you a function expression, which is the memory function where you have that function. So here you have to make the function call to return the output hello Python. Let's look at the second example. Here I have an outer function. I define an outer function that takes an argument y. Okay, I have a local variable x assigned to 3. Then I have an inner function that takes no input argument but returns the sum of x and y. Y is input from the outer function, x is a local function, the local variable. Now, right after that, outside the inner function, still inside the outer function, I have x incremented by 2 and then returning the inner function call. So what happens here is that you pass in an argument y, okay, and that argument is added to the value of x. What is the value of x in the outer function? The value of x is what is now 5 because x is being incremented by 2. Okay, this can be seen as writing this just immediately after I saying x equals plus equals 2. The same. It's like you write it this way, oftentimes not written this way, or it is written right, uh, right after x equals to, right after the inner function. So if we run this and we have our outer function namespace, we can of course call the outer function and assign it to out, and then our path will be 11. What will it return? It will return, of course, this is 11, and x is already what now 5, so we will return 16. Run this function, return 16. If you change this to 6, only return as well and run 11 because x is already 5 and you are passing in 6, this 11. Now, if I modify this outer function by coming right in here to do something here and assign y equals 4, what will happen here is that no matter the input you pass into the function, the outer function will always return the sum of x and y, which is local to the outer function. And what is x? 5. X is 5. And what is y? Y is 4. So it will always return 9. Let's see. If I run this and pass in an input function 6, returns 9. If you change this to what to 19, what will it return? It returns 9. In other words, the value of the input argument is not passed to the outer function. Why is this so? Because right inside the inner function, you have a local variable y, which overrides the input argument that you're passing. So let's remove this. I'm just trying to explain some things here. This is just an explanation of closures. This other example. In this example, I have a function R that returns x plus y, the sum of the input arguments. Now I want to uh, add another functionality to this function. In other words, I don't want to modify the add function, but I want to, pass that add function as a callback. In other words, as a function to another function. What will I do? I'll define another function calculate that takes in a function and what asterisk arg means it what it takes what now unlimited number of what now, of positional arguments. Okay, I don't want. I just leave them as asterisk arg. It gives me unlimited number of positional arguments, and it should return what the function of what of args. Okay, asterisk args. So if we run this, what do we have now? I want a result that would calculate by taking in this function add and then passing in these two arguments here, 2 and 3. What would that result? I'm printing result. It gives me 5. If I do likewise and pass 4, comma 5, what will it return? Return 9. So here I've simply done implemented a closure as a callback, okay, to pass in a function as an argument to another function. Those are how we can use closures. Next is decorators. Decorators, like I mentioned earlier, are also examples of closures. Okay, so here decorators are a design that allows you to modify the functionality of a function without explicitly modifying it. In other words, the outer function is called the decorator, which takes the original function as an argument and returns a modified version of it. Decorator classes can be used to implement a wide variety of functionality, such as logging, authentication, caching, performance measurement, and error handling. We can all use decorators to do this. Let's look at this first example. Here, I have um, uh, uh, I want to decorate a multiplication function. So here, so I define simple multiply. It takes in function, okay, and then I have an inner function, okay, which I call wrapper. You can call it wrapper, you can call it inner, you can give it any name. And this wrapper takes in args and keyword arguments. Okay, the result you return function of args and keyword arguments. Okay, and then return results. And then right inside the outer function, which is simple multiply, return wrapper. If you run this, we have the simple multiply already in the namespace. Now here we can now call or decorate another function now by calling this closure. So we say add simple multiply. Of course, at simple multiply, okay, it takes in a function. So what's that function it should take? We will define the function. The function is mul x1, x2, and it should return x1 times x2. Okay, it should return the product of two input arguments, right? So now let's print mul 20 and 12. Run this, gives us 240. What has happened here is that what we have simply applied a decorator, okay, a simple multiply to perform what now multiplication of what of 20 and 12, right? We have just decorated this function. Now let's see another example. In this example, I want to decorate another functions to repeat, for a specified number of times. So I'll define the function repeats and then how many times you should repeat times. Okay. Then I have an inner function, my decorator, okay, func, that takes in a function. And I have another inner function to my decorator that takes in the args and the keyword argument. Then for I in range times, what should happen? You should apply this function in the first inner function to the args and the keyword args. And then right outside the wrapper, okay, function, you return wrapper. So you are returning wrapper inside my decorator. And likewise, you are returning my decorator the function name inside the repeat. By this, we already have a closure. Now, what do I want to do now? I want to modify because I want to decorate another function. So I will call this my earlier defined function repeat. How many times? Four times. And I want to use that to decorate another function. In other words, I want to repeat x a couple of times. We can use this to actually write or build a multiplication table. There are a lot of applications of this. So here I define my func x, print x. Okay. And then what do I have? I use the at symbol, repeat. By using this, I'm decorating this function here using this already defined function repeat. Let's call my function 20. Now we are calling my func 20. If we run this, what do we have? Repeat 20. How many times? Four times. If I come here and say repeat it five and then call my func 20 again, it will give me repeat 25 times. So this is how we can use decorator. Okay, so first we have our closure here, and then we now use that closure to decorate another function. So here we have modified this function to do to repeat the input argument a number of specified times. Now, let's look at chaining decorators. We can chain decorators. What does that mean? We can have two decorators, okay? And then we can call those two decorators to modify another function. So here I have my decorator one taking a function. A decorator will always taking a function. And then you have an inner um, function, okay, which I call def inner that takes in the arguments now, the positional argument and keyword argument, and then the function should be applied on the argument rather should be applied on the functions we have from args and keyword args, and it should print the function name. As I say, print function dot name executed after decorator.name. In other words, this function is executed after the name of this decorator. And then right inside the decorator one, I return inner. Mind you, there is no function call it, I just return the inner function name. Go to decorator 2 and do likewise. Also do the same thing. Say this function, inner function here, is executed after the decorator. Okay. Dot name means is dot name will automatically pick the name of the inner function, the name of the decorator, and then you return inner. Okay, no function called inside decorator too. So we run this. What will happen here is that now you can call it in different order. First, let's start by calling decorator one and down to decorator two, add decorator one, and decorator. I want to decorate this function. Okay, which takes no input argument and returns none. Right? Now, calling my function, what would that give me? You see, it returns what? My function. Because I've called my function. So it's telling my function is executed after decorator 2 function. So first, this inner decorator 2 function is first of all applied to this function before this decorator 1 is applied to 2. So this is just like it's synonymous to like to like saying decorator 1 of decorator decorator 2 of my function like this. So this call is just synonymous to writing this, to, to writing this. That's what it is, right? Change this to 2 and this to 1. This changes the signature to calling decorator 2 on decorator 1 of the function. If we run this, what will it tell you? It says my function is executed after decorator 1, inner function executed after decorator 2. Let's look at this other example here. I have, I want to do catching here. Okay. Explain the use of catching. It helps us to efficiently manage memories when we are dealing with large array, okay, or large or something that requires intense computation. So I'll use the Fibonacci sequence as an example. We have written that function before. So here we define catch and it takes in a function. Okay, this is a closure. And then I'll call an empty dictionary, okay, assigned to catch. And then I'll call and define an inner function, which is wrapper. Call it anything. takes in args and keyword arguments. Then we have a key of this dictionary now to be args and keyword args dot item, okay, as a tuple. Then if key in catch, if this key, either of these two, if they are in catch, okay, return the catch of keys. Else, if they are not there, then the result should be apply these args to the function, this function, and then the catch of key equals to results. Okay, return results. Then right inside the catch function, which is outside the inner function wrapper, return wrapper, no function call, just return the function wrapper. Now, decorate this my function x that returns the square of x. Then I decorate it out with at catch. Now, if I run that, and then let me call my func 3, print my func 3. What will happen? Let's call my func 3. If I call my func 3, 9. Okay, it is added to that dictionary. Now, if I call again, print my func 4, and I run, it prints 9 and 16. If I call again, print my func 5, what? And run, or it prints 9, 16, and 25. Before I take this last example, let me demonstrate the Fibonacci sequence using catching. So here we define fib n. Of course, we're passing if n is less than 0. We should raise value error, and the value error should print that n must be non-negative. Non-negative. Must be non-negative. So I'll close it. Now, L if n equals to 0 or n equals to 1, okay, we should return 1. Else, else, one second, properly arrange my tabs. And else, what should we return? We should return, remember, returns the fib of n minus 1, the n minus 2. I'm doing recursive call here. Else, you return this. So now have my Fibo. Oh, sorry, this should be all corrected. So I have this in my namespace now. Now let's catch let's catch this, and I'll call the fib of 2, right? Catch, I'll call the fib of 2. What will I have if I run this? Fib invalid sync. Oh, sorry, to catch it, I need to call catch on this. Omitted, yeah, this is the right way of doing it. Open this again. I've called catch on it. Now let's call the fib of 2, and let's see what fib of 2 it is 2, right? Now let's call the fib of 20. You see, it picks that for us. So it means that if I simply do for I in range 1 and 20, I can print the fib of I. If we run this, what do we have? You see, it gives us the fib of up to 20. We can as well also put it, save it to a list or write it out on output. So we can see how here we have used the decorator catch to do what now? To execute our Fibonacci sequence easily. You can see the fib of 20 returned fast, unlike if you're just calling this recursive function, it takes a little bit of time to compute and return the value. So lastly, before end this video, I'll talk about decorating with classes. We're going to see this when we get to object-oriented programming. Actually, what decorator does is that it calls the double underscore, call dunder underscore. Okay, this dunder call method. So here we will have a class repeater. I will not dwell much on this. I'll just tell you that what we instantiate the class with number of times we want to repeat. And then we have a call method that calls a function and an inner function here wrapper that calls the argument. And then for I in main times, call the function of the class and keyword argument and then return wrapper, right? If we have these and then we come here, we now use the class now to decorate my function and run this prints 2020. So this is like decorating using a class decorator now, unlike the earlier example here when we use a function to decorate how many times we can repeat. The advantage of using the class decorator is that the class is reusable. We don't have to modify the class every time we want to call the decorator. We did come to the end of this video. If there's anything you want me to shed more light on, please leave it in the comment section. Like this video, share this video, and please subscribe to my channel if you have not done so. I will see you in my next video.